In this video, we are finding the domain of certain types of functions called domain restrictive functions. And we are looking at two specifically. One is radical functions and the other is rational functions. So basically those with a square root and those that are in fraction format. So let's start off with looking at the domain of radical functions. First, I want you to think about if you had the square root of x, okay? What values of x would make this square root of that value still a real number? Okay, so if you think about it, you can take the square root of 0, you can take the square root of 1, you can even take the square root of 2. It would end up being just a decimal, but you can do that. What numbers can you not take the square root of? And if you think about it, those are going to be those negative numbers. So like, for example, if I take the square root of -1, I'm going to get I, and those are not real values. So any negative number here is not going to be part of the domain of this function. We want basically all positive numbers, but we can also include 0. And so to figure this out, we want to find the domain by taking the radicand, that's the number or expression under that square root, and basically saying we want everything to be 0 or greater. So we want to set that greater than or equal to 0 and solve. So let's look at this example right here. Find the domain of f of x equals square root of x plus 1. We want to look at the x plus 1, that's our radicand, and we're going to take that x plus 1 and set it greater than or equal to 0 and solve that. So by doing that, we're subtracting 1, and that's going to give us x is greater than or equal to -1. Now, our domain, they want written as basically interval notation when you're doing inequalities. So interval notation here, again, if you think about a number line, you're shading to the right. So the number is going to come first, and because we have that line underneath, it's going to be a bracket. And if we're shading to the right, that's going all the way to positive infinity with the parentheses. Okay. Also, one quick note, if you have been following these videos, we have done function transformations. And if you think about what's inside, if I add 1 on the inside, that's moving the function left 1 unit. And so, looking at what would normally be the parent function, if I move it left 1 unit, now we're doing -1 to infinity, okay? And so that kind of is putting all of this together of all the things we've done so far. Let's look at the one below this. So we are trying to find the domain of f of x equals square root of 2x minus 1 plus 3. So we've got a couple extra things going on in this one compared to the previous one. We have the radicand is 2x minus 1, so that's everything underneath. But let's figure out what we're going to do with this plus 3. What does the plus 3 do when we're thinking about transformations? And this plus 3 is outside our parent function of square root of x in this case. And if it's outside and it's positive, it's moving it up. So if you're thinking about a square root function and you're moving it up 3, then you have not impacted the domain. You have only changed the range. So really, anything that's added or subtracted outside the function, you can just ignore because that's not impacting the domain, and that's what we're trying to find here. So the stuff inside, though, does impact that. And so we want to take our radicand, 2x minus 1, and again say we need it to be greater than or equal to 0. So we're going to add 1 to both sides. That will be 2x greater than or equal to 1, and then divide by 2. And we get x is greater than or equal to 1/2. Okay? All right, so that means, again, you're shading to the right. And so this would start out with the 1/2 with a bracket and go all the way to infinity. Now, I want to have one quick note here. If you end up with a problem that, let's say, is similar to this, but it ends up with a negative 2x minus 1, and this sign right there ends up being negative, all the same inequality rules apply. So if you divide by a negative, you flip that inequality over, and then you would be starting with negative infinity for the interval notation up to that number. So all those rules still apply even with the domain in this situation. Okay, so that is going to be our radicals. Let's look at our rational. So again, our rational functions, rational means fraction. That's what I always want you to think about. So we have a constant divided by a denominator. And obviously, typically that denominator is going to be some expression with x in it. Remember that we've talked about a few different times already that when you divide by 0, you are making that undefined. So basically, it is not okay to divide by 0 in math. It makes that expression undefined. So what we want to figure out is if we have a function, let's do a really quick, simple one. Let's say we have the function 1 over x minus 2. What value of x here would make the denominator of 0? Would make the denominator 0. Okay, so 2. If x is 2, 2 minus 2 is 0, and we can't divide it by 0. So basically, in this case, x can't be 2. So that's really what we're trying to find here is what value of x would make the denominator equal to 0. So our kind of standard form of looking at this is taking the denominator and saying, hey, this cannot equal 0. And we're going to set it to not equal to 0 and solve that. And that will tell me what number it cannot be. And then we'll go from there. So let's look at this example. We have a fraction and we're looking at the denominator, 2x minus 4. We're going to say this 2x minus 4 can't equal 0. Cannot equal 0. So plus 4 on both sides. That's 2x can't equal 4 and divide by 2. And now this is x can't equal 2. Now, I want to show you, since we haven't really seen this before, I want to show you what this looks like on a number line. So if we have a number line, and here's 2, this means that this can be everything but 2. So basically, you have a circle that's open, an open circle, a hole at 2. But it can be, and we can shade everything else. So all the way to the left and all the way to the right. So when I'm thinking about domain here in interval notation, I'm kind of thinking about this getting really close to 2 on this side and really close to 2 on this side, but never actually touching it. So when we're looking at the 2 part, we're thinking parentheses there. So I want you to basically describe this shaded area, just this left side, and then we're going to describe the right shaded area. So our left side, how far left does it get shaded? It's going to negative infinity. So we're starting at negative infinity, and then it's going all the way up to 2, but we're going to do parentheses because it's not actually going to include 2. And then it's skipping over, and it's starting at 2 on the other side. Now we're looking at this one, and going all the way to infinity. So you basically have 2 different intervals where that is describing basically the solution to this. However, we need something joining those 2 things together. And so in math, we are going to use basically a U shape with no tail on it. So don't write it like this, okay? That means union. So it's almost like joining 2 things together. We've got 2 intervals. We want to write it all as one solution, one domain, and one interval notation. And so this is how we do that. We use the U, the union, to put those together. So this interval notation, this domain is basically saying, hey, this is going to go from negative infinity to infinity, but take out 2. That's what this means, okay? Let's look at the one below this. So the one below it, we have an extra little thing on here. We have the plus 7 out here. And this is kind of the same idea as the one on this side, that radical that had a plus number. And again, this can be plus or minus. It really doesn't matter. But again, that is moving it either up or down. And that is impacting and affecting the range, not the domain. And we only care about domain for this problem. So we really only care about the denominator. We want to take that denominator and say, hey, this can't equal 0. So what number, what value for x makes this equal 0? And some of y'all can probably just look at this and see what works here or what makes it equal 0, but this ends up being 1. So x cannot be 1, but it can be everything else. So how do we do this? We're basically doing negative infinity to infinity, but we are taking out one and putting a union in its place. Okay, so that is how you do domain for radical and rational functions.